And let's assume we have a case for d parameter equals to 2. In other words, the maximum number of keywords we can maintain inside the node will be equal to 4, right? And let's assume if we do the insertion, and we have one node, after insertion, the number of keys inside it is 5. It's larger than the allowed maximum keywords inside it. In other words, there is overflow in this node. If so, according to the rule, we have to split these nodes into smaller ones, right? We also have to insert this K3 to the upper level to the parent node instead. How to split it? Let's assume we have K1, K2, K3, K4, K5. After insertion, we have 5 keywords. It's larger than the 2D, right? And we also have the 6 pointers, P0 to P5 is pointers. And we will do the insertion like this. We insert K1, K2 into one node. As to its pointer, it covers P0, P1, and P2 as its pointer. We also insert K4, K5 together with P3, P4, P5 into another node. And we insert K3 to the parent node. And so this K3 have a pointer. This pointer will be pointing to the right hand side of this node, this new node. And we'll have a special case. If this node is a leaf node, we will keep this K3 2 in the right node. In other words, if this node happens to be a leaf node, then the right node will actually be K3, K4, and K5, as is a keyword inside it. Of course, this K3 will also be inserted to the parent node as well if it is a leaf node. And if this one is a root, in other words, above it we have no other parent nodes anymore. If so, then the system will generate a new root instead. In other words, this K3 will be forming a new root. Because above it we have no parent, and this one will be directed by the new root instead. And this is also the reason why this root node has a special case for the degree. We allow this root node to be less than d, number of keywords inside it. Okay, so this is about the split rule for the nodes inside the B plus tree in the insertion. And let's come to the concrete example. Let's assume we have a B plus tree like this. We have 80 as the roots, and below it we have a bunch of nodes. These two are the internal nodes, and below them we also have this leaf node, right? And this pointer in the leaf node will be pointing to the concrete data tuples, storing the data instances in the database system, right? And here let's assume if we plan to insert a new key, right? K equals to 19. How can we do the insertion? According to the previous page, right? If we plan to do the insertion, the first thing we need to do is to find the leaf where the K belongs to. So if we want to insert the 19 into a B plus tree, we have to search for the position for the 19, right? We go from the root, going down, the 19 is less than 80, right? We go to the left branch, go to this node, right? And we compare the 19 with all the keywords inside it. 19 is less than 20. Therefore, we go to the left, the branch, right? Go to this node. Here is 19 is larger than 18, right? And inside this node, we can put 19 inside it, 19 here, right? And we also insert a pointer pointing to 19 as data tuples. This is instance, right? Therefore, if we do the insertion, we can insert 19 into this position, also add a pointer pointing to the concrete data tuple, storing the data instance, matching the keywords, right? So this is the insert of 19. This should be okay, right? Because after we do the insertion, this node is still be legal, right? We still have only 4 nodes. It is legal. And let's assume after we do the insertion of 19, we further insert this 25. How can we do this insertion? The process will be very similar. We search the position for this 25 first in the B plus tree. We go from the root, go to the left branch, go to this branch, right? Because 25 is larger than 20, smaller than 60. We go to this leaf node and find the position for the 25. It should be between 20 and 30, right? Therefore, between them, we have to insert 25 here, also at one point pointing to the 25, the data tuples. In other words, after we do the insertion, the nodes for the leaf node will be like this. We have 25 here. We'll have one pointer pointing to the 25, right? This data tuples. And after we insert this 25 into this node, we will have an illegal node, right? Because the degree in this node is 5 here. And here we have d equals to 2. In other words, this node will be illegal, right? And we have to do the split of these nodes into smaller nodes instead. According to the previous page, right, we do the insertion, split these nodes into 2, 20, 25 as one node, 44 and 50 as one node. Since this one is a leaf node, we also keep this 30 into the right node, right? Therefore, the new nodes we will have will be like this. We have 20, 25 as one node, right? It pointing to the data tuple, storing it. And for the rightmost pointer, it will be pointing to this right node. It's also a new node, right? In the right node, we have 40, 50. They pointing to the concrete data tuple, storing the data. Since this one is a leaf node, therefore we also keep a record of 30 in the right node. The pointer pointing to the concrete data tuple, storing the data tuple, matching 30, right, at the keywords. And at the same time, we will insert the 30 to the parent node, right? And in the parent node, since this 30 is between 20 and 60, therefore we insert 30 between them. We also add a new pointer pointing to the right node. You can follow me, right? This is according to our rule, right? This is our rule. Because this one is a leaf node, we'll keep the K3 in the right node as well. At the same time, we insert this K3 to the parent node. Also add one pointer pointing to the right node. This is the example for the insertion of the 25 into the nodes into B plus tree. We have to split these nodes into 2, and we also need to insert this 30, this key, to the parent node. Okay, so this is about the insertion. I hope you can follow me, right? I hope you still remember, right, before we mentioned B plus tree, the filling rate actually is less than 100%. In other words, for many of the nodes in the B plus tree, they will have some blank entries. This blank entry will be very helpful. The main reason is because if all the nodes in the B plus tree, they all fill out. If so, if we do the split of the nodes and also insert the key into the parent node, sometimes we may have to do the cascading splitting, right? We insert here, and if this one also happens to exceed the maximum allowed keywords, and we also have to split this one as well, right? And also have to split the further ones above them. We can avoid this case because we have some blank entry in the B plus tree, and after we do the splitting, we will create more blank entries in the nodes. This will be very helpful and also healthy for the B plus tree, and it can help avoid this cascading splitting in the B plus tree. Okay, so this is about the insertion of the B plus tree, and I hope you can follow me.